How to implement fault tolerance in cloud systems. Discover the essential strategies to ensure high availability and reliability in cloud environments, empowering you with skills to build resilient architectures.
In a world where digital presence is crucial, understanding fault tolerance in cloud systems can make or break a business. Did you know that every minute of downtime can cost a company thousands of dollars? Fault tolerance ensures your systems stay operational, even when components fail. In this video, we'll explore key strategies like redundancy, load balancing, and automated failover to help you build a resilient cloud architecture. Let's dive in. Fault tolerance refers to the ability of a system to continue functioning despite the failure of one or more of its components. In cloud computing, this concept is foundational to ensuring that services remain uninterrupted. Fault tolerance in the cloud is achieved through a combination of hardware, software, and process strategies. It ensures that user experiences remain seamless, driving customer satisfaction and trust. However, implementing fault tolerance comes with challenges, such as the complexity of systems and the cost of redundancy. Understanding these aspects helps businesses prepare and strategize effectively. Redundancy is a fundamental technique in fault tolerance, where critical components are duplicated to ensure that a backup is available in case of failure. In cloud systems, redundancy can be applied to hardware, software, and data. For example, data replication involves maintaining copies of data across different servers or locations. This ensures that if one server fails, data can still be accessed from another location. While redundancy increases reliability, it also introduces complexity and cost. Therefore, businesses must carefully plan their redundancy strategy, considering factors like geographical diversity and data synchronization. Load balancing is a process where incoming network traffic is distributed across multiple servers to ensure no single server becomes overwhelmed. This not only optimizes resource use but also enhances fault tolerance. By spreading the load, load balancers prevent system overloads and improve overall system reliability. There are different types of load balancers, including hardware, software, and cloud-based solutions. Each has its own advantages and is suited to different scenarios. Selecting the right load balancer involves understanding your system's needs and considering factors like traffic patterns and scalability.
Cloud services and APIs play a crucial role in building resilient systems. Managed cloud services offer built-in fault tolerance features, reducing the need for businesses to build from scratch. For example, services like AWS Elastic Load Balancing and Google Cloud's Load Balancing are designed to automatically distribute traffic and handle server failures. APIs allow for seamless integration and automation, enhancing system resilience. By leveraging these services, businesses can simplify their architecture, increase reliability, and focus on core functionalities. It's important to evaluate cloud providers and select services that align with your fault tolerance goals. Automated failover is a critical strategy in fault tolerance, ensuring high availability by automatically switching to a standby system when the primary system fails. This minimizes downtime and maintains service continuity. Implementing automated failover involves setting up backup systems that can take over without human intervention. Examples include database failover clusters and DNS failover. Regular testing and monitoring are essential to ensure that failover mechanisms work as expected and can handle real-world failures. Automated failover not only enhances reliability but also provides peace of mind, knowing that systems are always ready to recover from disruptions. Effective monitoring and alerting are vital components of fault tolerance, allowing for the early detection of issues before they escalate into major problems. Monitoring tools track system performance, resource usage, and potential errors, providing insights into overall system health. Setting up alerts ensures that IT teams can respond quickly to faults, minimizing downtime. Analyzing monitoring data helps identify patterns and areas for improvement, leading to enhanced reliability and performance. Popular tools like Prometheus, Grafana, and AWS CloudWatch provide comprehensive monitoring solutions tailored to cloud environments.
Learning from real-world case studies offers valuable insights into successful fault tolerance implementations. For instance, Netflix's use of chaos engineering to test and improve their system resilience is a prime example of proactive fault tolerance. Another case is from Amazon, which leverages a combination of redundancy, load balancing, and automated failover to maintain a seamless customer experience. These examples highlight the importance of continuous testing, strategic planning, and using advanced tools to build robust cloud systems. By analyzing these cases, businesses can identify best practices and tailor strategies to their unique needs.
The future of fault tolerance in cloud systems is evolving rapidly, with emerging technologies and trends shaping the landscape. AI and machine learning are playing increasingly significant roles, providing predictive analytics and automated responses to potential faults. Evolving cloud architectures, such as serverless computing and edge computing, present new opportunities and challenges for fault tolerance. As technology advances, businesses must stay informed and adaptable, ready to integrate new solutions that enhance reliability and performance. By preparing for these trends, organizations can ensure they remain at the forefront of innovation and resilience.
In conclusion, building a resilient cloud architecture requires a comprehensive understanding of fault-tolerant strategies. From redundancy and load balancing to automated failover and monitoring, each component plays a crucial role in ensuring high availability and reliability. As you implement these strategies, remember that proactive planning and regular testing are key to success. We'd love to hear about your experiences and challenges in implementing fault tolerance. Share your thoughts in the comments. Stay tuned for more content on cloud innovations and strategies.